Okay, let's just dive right into this explainer. We're looking at how human ingenuity is literally reshaping the global cooling industry. Think about it. We rely on refrigeration and AC for, well, pretty much everything. Preserving our food supply, keeping our homes livable, running massive data centers. But that innocent-looking fridge sitting in your kitchen right now, it actually holds a massive chemical secret with a profound impact on our planet. Today, we're going to trace a really fascinating technological evolution. We're going all the way from an environmental crisis in the 1980s straight through to the sweeping regulations that are transforming the exact machinery we use today.
Now, when I first saw this number, it honestly stopped me in my tracks. 0.4 degrees. A single, unified global policy shift regarding refrigerants is projected to prevent exactly 0.4 degrees Celsius of global warming by the year 2100. And you know that when we talk about climate change, every tiny fraction of a degree matters immensely. It's the difference between saving or losing entire ecosystems. So as we're going to unpack here, the heating and cooling industry is pulling one of the absolute largest single levers we have to alter our climate trajectory. So, here's our roadmap for today. We'll cover saving the ozone layer, the plot twist of the Kigali Amendment, global phase-down timetables, the U.S. AIM Act, and finally, the new age of cooling.
Let's jump straight into Section 1, Saving the Ozone Layer.
You know, to understand where we're going with modern cooling, we absolutely have to understand where we started. The Montreal Protocol was adopted globally to eliminate chemicals that were literally, and I mean literally, destroying the Earth's protective ozone bubble. That bubble acts as a vital filter for the sun's harmful ultraviolet radiation. Back in the early 1970s, scientists made this startling discovery. Human-made emissions, specifically CFCs and later HCFCs, were just eating away at this essential barrier. And the world realized, wow, we have to act, and we have to act fast.
And it's actually incredible to look back and see how quickly the global community mobilized. I mean, from the alarming scientific discoveries in the 70s to the Vienna Convention in '85 and then the landmark Montreal Protocol in 1987, by 1996, the production of the most damaging, high ozone depletion potential refrigerants was effectively halted. It was a monumental victory, a real blueprint for global collaboration.
But that brings us to Section 2, the Kigali Amendment plot twist.
Okay, so here is the major plot twist in our story of fixing the sky. Solving one massive global problem actually completely inadvertently laid the groundwork for another. To replace those ozone-destroying CFCs, the chemical industry developed new refrigerants called HFCs. Now, they had zero ozone depletion potential. That was a huge win, right? Exactly what the Montreal Protocol demanded. But, unfortunately, they turned out to be incredibly potent greenhouse gases. So, while they didn't harm the ozone layer, they had massive global warming potential. We're talking about trapping heat in the atmosphere at rates sometimes thousands of times greater than carbon dioxide.
So to correct this unintended consequence, the world had to come together all over again. In October 2016, over in Kigali, Rwanda, more than 170 countries agreed to explicitly phase down these superpolluting HFCs. This agreement, the Kigali Amendment, it's easily the most significant change to the Montreal Protocol since the 90s. And what's clever here is that instead of just measuring chemical mass, this new phase-down is uniquely measured in CO2 equivalents. It directly targets their climate impact. And listen, this right here is exactly why this matters so much. This specific, highly targeted international treaty is exactly what makes that incredible 0.4 degrees Celsius of climate savings possible.
Let's move on to Section 3, Global Phase-Down Timetables.
Now, phasing out a chemical used in literally billions of appliances globally, yeah, that doesn't just happen overnight. This strategy actually reveals a very intentional focus on equity under the Kigali Amendment. Developed nations lead the charge. They started their phase down in 2019 with a really strict target, an 85% cut by 2036. Meanwhile, developing markets are split into two groups and are given a bit more breathing room, freezing their baseline consumption in either 2024 or 2028. This staggered approach is incredibly important. It buys vital time for new, cost-effective cooling technologies to actually reach emerging markets without, completely stifling their economic growth.
Which brings us to Section 4, the U.S. AIM Act. Let's focus our lens locally for a second and see how this global treaty is being implemented right here in the United States. Passed as part of a stimulus bill back in December 2020, the AIM Act was a total game changer. See, for years, the EPA faced major legal hurdles if they tried to regulate refrigerants based solely on their global warming impact. But the AIM Act, it finally gave the EPA the formal, undeniable authority to regulate substances based specifically on their GWP. This law mandates a massive 85% phase-down of U.S. HFC production and consumption over 15 years. It essentially forces the entire industry to abandon legacy refrigerants.
And that translates into a really strict, step-by-step, phase-down schedule that the US industry absolutely must legally follow. We've already blown past the initial 10% reduction in 2022 and that aggressive 40% cut in 2024. But the pressure ramps up significantly by 2029 with a 70% reduction, culminating in that final 85% cut by 2036. So it creates this highly predictable, albeit super aggressive, roadmap for equipment manufacturers. They essentially have to re-engineer their entire product lines.
And that leads us perfectly into Section 5, the new age of cooling.
So, what does this actually mean for the hardware sitting in our supermarkets and our homes right now? We've talked about the laws, the history, but what's physically going into the pipes being built today? Well, it means that GWP, global warming potential over a 100-year lifespan, is now the ultimate metric. It alone decides which refrigerants survive and which go extinct. Simply put, if a substance traps too much heat, its days are strictly numbered.
To meet these strict new limits, the industry is rapidly pivoting to a whole new generation of alternatives. First up, we've got HFOs, which have zero ozone impact and very low global warming potential. Then we have A2L refrigerants. These are blends like R454A and C. But honestly, here's the part I find highly ironic. After decades of developing these super complex synthetic chemicals, we are essentially going right back to basics. We're using naturally occurring substances that were used over a century ago, like carbon dioxide, or R744, and propane, known as R290.
But there is a catch here, one I hadn't actually realized at first. Because things like propane are naturally flammable, and the new A2L blends have mild flammability, you can't just casually drop them into an old air conditioner. The whole industry has had to completely rethink safety. Organizations like ASHRAE are simultaneously updating strict safety codes to ensure that these modern, eco-friendly systems are designed, installed, and serviced safely in our communities.
And to make this massive industrial shift both safe and legal, the EPA uses its SNAP program. It sets hyper-specific rules for exactly how we build the future of cooling. Rule 26 is a perfect example of this. It sets specific GWP limits like 150, 300, or 1400, depending on the exact size and type of commercial refrigeration you're looking at. Crucially, it also updates equipment rules, like allowing larger charge sizes of up to 494 grams for propane in open retail equipment. It's a really careful balancing act between our climate goals and the physical engineering realities of making these systems actually work on a commercial scale.
So, looking back, the journey from the original Montreal Protocol to the Kigali Amendment and the AIM Act is just this incredible story of ongoing global collaboration. We literally fixed the ozone layer, realized we inadvertently created a massive climate issue, and now we're engineering our way out of that too. But as our warming world demands more refrigeration than ever before, it leaves you wondering, what will the next generation of thermal management look like in 2050? We've tamed CFCs, HCFCs, and HFCs, but I'd argue the quest for the truly perfect zero-impact cooling technology is really just getting started.